So if we discuss about your routing, network routing is the process of selecting a path across one or more networks. Okay. How selecting a path across one or more networks? You can consider the example. Let's say, for example, you are right now in Bangalore. You want to go to Delhi. Correct. Now, what all the mediums are available to you? You have like flight. We have flight, we have train, we have bus, we have car, bike, cycle, and even you can walk. These many possibilities are there. Now again, with each and every possibility, these are the mediums. These mediums you can consider as these are your routing protocols. These are what your right. But what is your routing? Selecting a path across one or more networks means one or more paths. You have more than one possibilities. Okay. Now let's say you want to choose flight. When you want to choose flight, again, there are some direct flights, there are some connecting flights, and maybe you'll go around the world and then you'll go to Delhi. That's another path. So how many possibilities are there for the path? Means if you want to go from Bangalore to Delhi, maybe you will go via Hyderabad, you will take a direct flight, you will go via Pune, you will go via Bombay, you will go via Goa, right? Multiple possibilities are there. Now, how do you select the flight, for example? Or before that, you have to select a routing protocol, that which routing protocol you are going to use, right? So how you will compare between all these things, that which thing you are going to take if you want to travel from Bangalore to Delhi? How you're going to decide? Now, to some people, flight is a good option. To some people, it is expensive, so they will prefer either train. Because let's say, for example, if they want to travel from Bangalore to Delhi, if they are taking up a flight, it will cost them around 8,000 rupees. And in the same place, if they are taking a sleeper class train, it will cost them around, let's say, at 50 rupees. Now, some people will compare what? The price. Right? The criteria for comparison is different. Some will think, okay, cost, we will go via train. Now, some people will think about the time. Okay, train will take 2 days, flight 2.5 hours. Now, some people will consider what? Time. So they will choose what? Flight. Okay. So like this, there are different criteria. Similarly, we have different routing protocols, and each and every routing protocol, they have their own way to decide that, okay, which path will be the best path, right? And when we want to decide the best path, what we are going to do, we are going to compare. Because again, when you want to take a flight or train or bus or car, we have endless possibilities to reach from source to destination. Okay, we have endless possibilities to reach from source to destination. There is n number of possibilities. But again, which one you are going to choose? Because you can walk from only one path. At a time, you can walk from only one path. Similarly, your data can be delivered from one path only. And which path you are going to prefer? Let's say from here, if you want to go to your home, there are multiple ways. Maybe there's a way it will take 5 minutes only. Maybe there's a way it will take 3 hours also. Right? But still, which one you are going to choose? Shortest one? You will always choose what? The shortest one. What if the shortest path is muddy? It's full of mud. Now what? Will you still choose the shortest path? See, it depends on the factor, what you compare. If you compare time, according to that path will be the best path. Now, if you want that, okay, time should be okay, but also the path should be good. More possibilities, then more filters. Okay. So like this, we have different routing protocols, and each and every protocol will have different set of criteria to compare between the best path. Okay. Now, based on the criteria only, the best path will be calculated. That, okay, which path your router is going to take to forward the packets from source to destination. Okay. And this process of selecting the best path across multiple paths, this is known as your routing. Okay. Now, the principles of routing can apply to any type of network, either it is telephone networks or your public transportation. Can be anything. Okay. In packet switching networks such as internet, routing selects path for the IP protocol packets to travel from their origin. What is origin? Source to the destination. Who makes these decisions? Router. So these internet routing decisions are made by specialized piece of network hardware called routers. Okay. Your routers are responsible for routing. So if you want to take up the best path, your router is going to select the best path. That path will be known as your route. Let's say you're searching to go to some place in the Google map. Now there are again multiple possibilities, but what your Google map shows? The best one, right? It will compare different criteria like, okay, which is the shortest one, in which there is less traffic, okay, where the maintenance is not going on, where the toll is not there, okay, these kind of things. So if we discuss what is a route is the best path. This is the best path selected by a router to reach from source to destination. Then we have the routing table. So what is the routing table? Now the collection of routes is the routing table. It is table that is going to contain all the routes. Okay. Now, one more thing. It is the collection of what? Routes. Right? It is the collection of route. And what is a route? Best path. So that means in your routing table, only the best path will be stored. If there is an alternative, it will not be displayed inside the routing table. It will not be stored. Only and only your best paths will be stored in the routing table. What is an IP? The internet protocol specifies the origin and destination for each and every data packet. IP address. Okay. Router inspect each packet's IP header to identify where to send them. The router will always check the destination IP address. This is clear. Now we have different types of routing. You have static route, you have dynamic route, you have default route. Okay. Basically, you can consider static and dynamic only. Why? Because your default is a special case for static route only. Means there is no difference in defining them. It is just a special condition, you can say. Okay. So if we discuss about your static, default, and dynamic. Okay. So static route. What is static? What does the static word mean? Manual. Static means manual.
So it means fixed.
That is not changing. Right. So static means it is fixed. So how it is fixed? Because we are going to manually define. Your router will not calculate on its own. You will define the path. The admin will define that, okay, this is the path it is going to take. Okay. So here what is going to happen? The admin has to manually define. Okay. The admin has to manually define a route. For each and every destination. For each and every destination network. This is kind of situation where you know each and every street of your city. Now anyone is asking, okay, I want to go there. You will tell them, okay, this is the good path. You go through there. Okay. This is your static route. That you will say, okay, go take this path. So they will take that path only. Once defined, that is fixed, not changing. Okay. Then we have the default route. What is the default route? Again, a special case of static route only. So if static routes are manually defined, your default routes are also manually defined. Okay. So see, static route, for each and every destination, you will define a separate path. For static route, you will define separate path for each and every destination. Okay. But in case of default route, we will define only one route. Yes, just one route for each and every destination. Okay, here, if you want to reach 100 networks, you have to define 100 paths. Okay, but in the default route, if you want to reach thousands, 10,000, doesn't matter how many, only one path.
It covers all different paths.
Yes, all the paths. Okay, so this is kind of situation. Someone is coming to you asking, let's say, I want to go to Delhi. You'll tell them go to the airport, right? Someone will say, okay, I want to go to Bombay, go to the airport. So to each and every, whatever someone is asking you, you're just saying one thing, what? Go to the airport. Means you are just forwarding them to the next thing. Now you don't care how they will reach. That is headache for the next person. But you'll just tell them, okay, go to the airport, buy a ticket, and just go anywhere you want to. Now, is it not the correct thing? If you want to go to any city, you just go to the airport and take the flight, and you can reach there, right? So ultimately, what you're doing from your side, you're just forwarding it to the next person, to the next destination. You're telling them go to the airport. Similarly, in the default route, what we'll say, we'll forward all our traffic. Doesn't matter to which network it belongs, where it is going, we don't care. We just want to forward it to the next hop or next router that is provided. That is the default route. So in case of default route, what is going to happen? The admin has to manually configure a default route for all the destination networks. For all the destination networks. Okay. For each and every destination network, what will happen? Only one route. Okay. Then we have your dynamic routing. So here we have to manually do it. Dynamic is what? Automatic. Okay. So here the routing decisions will be made by routing protocols. In case of your dynamic routing, the routing decisions will be made by your routing protocols. Okay. Your routing protocols will decide that, okay, which path will be the best path. Okay. So in case of dynamic, if you want to define, you can say the routes are automatically defined with the help of dynamic routing protocols. Here, your dynamic routing protocols, they are going to decide which path your router is going to take. Okay. Noted. Now, your dynamic routing protocols, they are divided into two categories. One is the IGP and second is the EGP. IGP and EGP. If we discuss about your IGP, one is IGP and second is EGP. IGP stands for Interior Gateway Protocol. IGP stands for Interior Gateway Protocol and your EGP stands for Exterior Gateway Protocol. Okay. Now, what is the difference? IGP and EGP. Anyone?
It's inside, and because for example, one network has connected with another. That time with ECP.
So
That is
everywhere,
at board times, at border side.
Exterior is responsible for the different networks.
so every entire routing is responsible for different networks,
Basically, for
Different areas, right?
different areas.
Some.
why did they
The term you're looking for is AS, autonomous system. Okay. Your IGP protocols, they are providing communication only for same autonomous system, and your EGP, they are providing communication between different autonomous systems. Okay. Now, what is an autonomous system? If we discuss what is an autonomous system. So autonomous system is nothing. You can say a number of routers or group of routers that is configured and managed by a single organization. Okay. You can say number of routers configured and managed by a single organization. That is your autonomous system. Okay. So means, let's say This is my Bangalore branch having some routers. Okay. And they are connected to each other. Now they want internal communication within the branch communication. Okay. So these all the routers, they are configured and managed only by the Bangalore branch. So this is one autonomous system, let's say AS1. This is configured and managed by one organization, one branch, that is one autonomous system. Okay. So for the internal communication, which protocols they will be using? IGP protocols. Okay. They'll be using RIP, IGRP, OSPF, ISI, CIGRP. These are the protocols. Similarly, let's say this is the branch at Delhi. Again, they have some routers connected to each other. So for internal communication, what they will be using? IGP protocols, because again, for them also it is internal communication. But whenever they want to communicate with each other, now this is one autonomous system, this is different autonomous system. Then in that case, they will be using the EGP protocols. Inside internal communication, IGP. External communication, EGP. Same AS communication, IGP. Different AS communication, EGP. Is that clear? Okay. Now again, your IGP protocols, they are further divided into three categories: distance vector, link state, and hybrid. Okay. So what is distance vector, what is link state, and what is hybrid? We'll see. These are nothing but different approaches, you can say. Okay. How they are different approaches? Let's say, for example, let's consider a topology. This is the source router. This is the destination router. Okay. And we have multiple paths to go from source to destination. Let's say like this, we have multiple paths. This is source, and this side we have destination. Now, if we are considering distance vector protocol, so distance vector, what it is going to check? Only and only the distance. Doesn't matter that what is the bandwidth, what is the speed, nothing. Only cares for distance. Okay. And how does it focus on the distance? With the help of number of hops. What is number of hops? It is just going to count how many routers are there in between the source and destination. Okay. So according to distance vector protocol, they will check, okay, how many paths are there? Possible paths? 3 paths. Correct. Now through the first path, if I start from the source, I have one router and two routers from the first path. First path is having 2 hops. Okay. From the second path, starting from the source, only one. From the third path, 1, 2, and 3. Okay, 3. Now it is going to always check what is the shortest path, right? So according to this, which path is the best path? Right? Means your distance vector protocol is going to forward the traffic through this path. Correct? This is your distance vector protocol. Next is your link state protocol. Now your link state protocols, they focus on the bandwidth. They focus on bandwidth, they do not focus on the distance. Okay. Now let's consider this speed of this link is 2 Mbps. Speed of this link is 10 Mbps. Okay. And let's say this is 1 Gbps. Okay. This one, let's say 1 Gbps. According to link state protocol, they will check for the bandwidth. Now it will not check how many hops are there. It will check what is the bandwidth. It will check, okay, through the first path, I have what? 10 Mbps. Through the second path, I have 2 Mbps. Through the third path, I have 1 Gbps. Now, which is the best one? Third. So it will take what? This path. It will forward it through this side. Now, in the real scenario, if you were in a company, which protocol would you prefer?
Who is
No, I mean distance vector or link state. Link state. Why? Because if you take this path, maybe it is the shortest one. It is having only one hop. But if you consider, if you want to travel, if you want to transfer, let's say 1 GB of data, here, how much time it is going to take? In 1 GB, how much MBs are there? 10, right? 1024, 1024. So divide by 2, because this is your speed. How much time it is going to take? 512 seconds. Right? Can I say approximately 10 minutes, like 600 seconds? So 9 to 10 minutes it will take, right? And here through this path, 1 second, right? So this side it will take less time. So that's why this is a better protocol. And this is the reason your distance vector protocols are not in use anymore. Okay. Then we have hybrid. Now, what is
the difference between speed and bandwidth? Speed and bandwidth.
Speed is the actual data transfer rate, what you get. And bandwidth is the maximum throughput. Let's say, for example, when you are saying that, okay, I'm buying 1 Gbps connection, same thing. There also I said that is your bandwidth. They are telling you that, okay, this is the maximum throughput you will get in the bits. Speed is in the bytes. Okay. So speed is actual data communication speed. Bandwidth is the maximum throughput. That is the maximum value. But speed is what actually you're getting. That is. Okay.
Ajay,
Yes.
I have one doubt.
Yes, please.
In the distance vector protocol, right? Like for path 1, we have 2 hoops. For path 2, we have 1, right?
Yes.
So if in case, like let us consider the path 2 also 2 hoops. So which is the minimum is like now the 2, right? Among the 2 paths, which one it will choose actually?
Can you please repeat?
Actually, let us consider in the distance vector protocol, we have path 1, path 2, path 3, right?
Correct.
So in the 3 paths, we have a different hopes actually. 2, 1.
Yes.
If in case both the path 1 and path 2 having the 2 hopes.
Okay. That in that case, there will be load balancing. If you are saying, let's say this path is also having 2, in that case, there will be load balancing. Means
Okay.
1 packet through this path, 1 packet through this path.
Oh, okay.
Okay. They will do the load balancing. Then we have, see, hybrid protocols. So in the hybrid protocol, what do you mean by hybrid? Mixture. So it has the features of both your distance vector also plus link state also. That's why they are known as hybrid protocols. Okay. Then in the EGP, we have only one protocol, that is your BGP. Only one single protocol used for the internet communication, you can say. Okay. Only one protocol is there, BGP. This is clear. So these are all the protocols that are available. Now, according to our CCNA syllabus, okay, according to our CCNA syllabus, if we discuss, so you have static, default, and in the dynamic, only you have OSPF. And in the OSPF also, you have just single area OSPF.
Like you remove the EAGRP.
Everything has been shifted to CCNP. Okay.
RIP is also hard.
RIP
And
is obsolete, not being used.
they removed it.
Yeah, removed it. See, we saw, right? If you remember the first day modules, let me show you again.
BGP will not use CCNP.
Yes.
BGP.
BGP CCNP. Yes. CCNP routing, you will study BGP. See, this is IP connectivity. about your routers. So we have components of your routing protocol, like what is a routing protocol: prefix, network mask, next hop, administrative distance, metric, gateway of last resort. Okay. Then how your router makes the forwarding decision. IPv4 and v6, static routing. So in the static also we have depot, network, host, and plotting. And in case of dynamic, what it is: configure and verify, single area was pure version 2. That's it. Then you have FHRP, and this is done. Only this much routing is there. Okay.
What are the things till now we covered actually in the syllabus?
Yes.
What are the things we covered, Ajay, till now in the syllabus?
See, we are covering this part in our own way. Okay. Everything will be covered. That you don't worry. Okay. Like,
Okay.
yes. Still, we are covering the basics only. Now we will cover all the topics.